Okay, so here's the second problem. So B, our second matrix, is 3, 2, minus 5, minus 3. And in this case, we're supposed to show that B to the 1024th, here the numbers actually don't get large at all. It turns out B to the 1024th power is the identity matrix.
All right.
It's kind of a surprise.
So we're going to do the same thing here. Add our lambdas in. So we solve 3 minus lambda, so minus 3 minus lambda, minus 10 equals 0. So minus 9. Or minus 10 is plus 10. So minus 9, minus 3 lambda, plus 3 lambda, so no lambdas, plus lambda squared, plus 10 equals 0. Or lambda squared plus 1 equals 0. This doesn't have any real solutions, so lambda equals plus or minus I. It still works though, so I minus I 0, 0, like that, and then times x inverse x for two other matrices.
Alright.
So we know that I plus or minus I to the 4th equals 1. So I to the 1024, since that's a multiple of 4, is going to equal 1. So we in the middle we get the identity matrix when we raise it to the 1024, and then since these multiply to be the identity matrix, when you put one in and then put the other in, multiply the first one and the second one in, you're still left with the identity matrix.
Okay, cool. So it's a real surprise. And I think that's part of what this problem is trying to show. That it becomes pretty difficult to know ahead of time what a matrix is going to look like. So this one, what was it, 3, 2, 1, 4? Is this, you take larger and larger powers of this one, you get bigger and bigger numbers. This one, 3, 2, minus 5, minus 3. Interestingly, this actually has sort of numbers that are larger in magnitude than this one. This one actually, what do you think is going to happen as I take powers of this one?
Well, you think it would just kind of bounce around, like between large and large negative, but it doesn't.
What happens when I raise to various different powers of this one?
What do you mean? It's going to go to the.
If I take b squared, yeah, b cubed, b to the 4th, b to the 5th, etc.
It eventually starts looking more and more like the identity matrix. So these terms go to 1 and these terms go to 0.
Ah, okay. So what do you think? How do you think that happens? Do you think that happens over time?
I would think. It doesn't seem like it would happen all at once, but it looks like it kind of bounces around a little bit.
How many?
So maybe a cycle of 4.
Why? Why do you think it might be a cycle of 4?
The powers of I.
Yeah, that's exactly what happens. The power it cycles in powers of 4. Every 4th power is the identity matrix. Because the eigenvalues were I. So this one goes in a cycle. This one just gets larger and larger and larger. Now we'll look at the next interesting example.